In this video, I will go over the Test 2 non-calculator study guide questions. For this first one, we're finding the sum. So the sum means we will add the like terms. So 12 minus 5i, you can rewrite it so that you can line up the like terms. 4 minus 3i, lining up those like terms so that you can add them. So that's 16, and then negative 8i. Not I squared, because we're not multiplying. So the answer is 16 minus 8i. Number 2, we're going to factor. We always want to look for a GCF first. So these three terms have an x in common. So factor that out front, and our leftovers we'll have x squared plus 6x plus 8. Once you factor out the GCF, you actually can factor this trinomial using product sum. So with the product a times c, so 1 times 8, a product of 8, and a sum of 6. So 2 and 4 will work. So we can rewrite, replacing the middle term with those two numbers we picked, 2x and 4x. And we'll do factor by grouping. Group the first two and the last two terms to factor out the common factor. Remembering all along to bring down that GCF that you factored out at the beginning. So the first group has a x, and the leftovers are x plus 2. The second group has a GCF of a 4, and its leftovers are also x plus 2. We do want those leftover parentheses to match. So our final answer, bringing the GCF out front from the beginning, and then we write our two sets of parentheses from our work here. So x plus 4 make one of the parentheses, and x plus 2 make the other. Let's look at number 3 now. We're going to solve this equation, and you can do that by two different methods. First, we're going to do it by the square root principle. So the square root principle just says when we have something squared, we can solve by undoing by taking the square root, and we'll want the plus and minus square root. But before we can do that, we actually have to move this 36 away. So think about reverse order of operations, adding and subtracting. We have that, so we will need to undo the subtraction by adding. So x squared equals 36. Multiplication and division, we have none, so we'll move on to exponents. To undo that exponents, this is where we take the square root. We will want to take the plus or minus square root of the 36 to make sure we get both solutions. The square root of 36 is 6, so we have the solutions of positive and negative 6. So in set notation, we list those least to greatest in those brackets. Let's solve this by another method of factoring. So to solve by factoring, we first need to find what kind of factoring we should do. Well, let's first look for a GCF. We do not have any common factors. So now with two terms, we should try to factor the difference of squares, and that is what that is. So the square root of each term. So we do x and a 6, x and a 6, and just like when you take the square root to solve, we need a plus and a minus for our factors. But we actually have to solve by factoring. That's the factoring work. Now let's set them equal to 0 so we can solve each of them for our solutions. The first factor, we'll subtract 6 to get x equals negative 6. And then the next factor, we'll add 6 to x to get x equals positive 6. So we notice we do get the same two solutions even though we solved it by a different method. Now let's look at question 4, probability. We have two 8-sided dice that are rolled. Find the probability of rolling a number less than 4, so a number less than 4 on the first roll, or the first die, and an 8 on the second die. So first of all, recall that and means we're going to multiply. So we need our fractions. A number less than 4, so on an 8-sided die, there are 3 numbers that are less than 4. 1, 2, and 3. So 3 out of the 8 represents that first fraction. And we're going to multiply an 8 on the second die. There is only 1 8 on that dice whenever you roll it. So it's not 8 out of 8. Just because we're talking about the number 8, there's only one of those. So we multiply those fractions. 3 times 1 is 3. 8 times 8 is 64. And because this is the non-calculator portion, that is a good place to stop. It would be difficult to write the decimal and percent from here. Now a number cube is numbered 1 through 6. What's the probability that you roll a 1, or a 5? So here we have to know an or statement. We're going to add the fractions. So a 1, there's only 1 out of the 6 sides, and there's only 1 out of 6 sides of the 5. Not 5 out of 6. That would be saying there's 5 5s on that number cube, and that would be incorrect. There's only 1 1 and 1 5 out of the 6 sides. So add those fractions. Gives us 2 out of 6. You should be able to reduce this without a calculator. That gives you 1/3, which is 0.33 or 33%. So for an and probability, you multiply. For an or, you add. And notice for this addition, we did not have to subtract out any overlap. You cannot have a 1 and a 5 at the same time. But that could occur with probability when you're doing an or statement. Let's take a look at number 5. The sample space is the numbers 1 to 12. Set A is the odd numbers, and set B are the prime numbers. So it helps me just to kind of list those out and provide a Venn diagram in order for me to answer the sets that it's asking for. So odd numbers, 1, 3, 5, 7, 9, and we're going up to 12, so we need 11. 1, 3, 5, 7, 9, and 11. And then our prime numbers are 2, 3, 5, 7, 11. So for our Venn diagram, which helps just kind of show a visual of what we're looking at here, we would have set A being all the odd numbers, and set B being the prime numbers. And of course, if they're in A and B, they will be in that intersection. This is set A, this is set B. So A, we have our odd numbers, but if it is an odd number that's also a prime, it would go in this intersection. So 3, 5, 7, 11 are odd numbers that are also prime. But 1 and 9 are just odd and not prime. So they would live in that just A circle portion, where these that are odd and prime live in the intersection of both of those circles. So in the set B circle, we want to list our prime numbers. We have all of them already listed except for 2. Because 2 is not odd, it comes over here on its own, where 3, 5, 7, 11 are already placed because they are odd and prime. Of course, if we're talking about our entire sample space, one, 2, 3 are all represented, but 4 would live outside of those A and B sets. 5, 6, 7, 8, 9, 10, 11, and 12. So these numbers that are not odd, not primes, they would also be represented out here. So let's talk about these sets that it's asking for. We want to find the set of A and B, or you can read this as set A intersection B. So that symbol stands for and. Stands for an and, which is a intersection. So it is that intersection of A and B. So it is the set from least to greatest, 3, 5, 7, 11. We want it to be a odd number and a prime. So this symbol stands for or union. So we want it to be in set A or B. Unite them, marriage them, union all together. So we want to list them again, least to greatest. 1, 2, 3, 5, 7, 9, 11. Union stands for or. These are the numbers that are in set A or B. Unite them together. Now for question number 6. We're going to use similarity rules to determine if the triangles are similar and write a similarity statement. Well, first we notice angle E and angle L. So angle E is congruent to angle L because they both are shown as the measures of 102. We have this angle F, which is 30 degrees. I'm hoping that if we can show that angle M is also 30 degrees, that will be enough to prove it with angle-angle similarity. So let's find the measure of angle M. So 180 minus 102 and then we also want to subtract the 48. That's perfect. That's exactly what we need, is 30 degrees. So angle M is 30 degrees, which ends up now matching angle F. So angle M is congruent to angle F. So that is enough to say angle-angle similarity. You could have also shown that G matches up with N, because it would do that. But this is enough just to show these two pairs. We don't have to show all three. So let's name our first triangle. So triangle, however you want to name the first one. I'm going to start FEG. Whatever name you pick for that, you have to line up the corresponding pieces of the other triangle. So that is similar to triangle. So if we started with F, we just found out that F corresponds to M. So M has to be in our name for our similarity statement as well. F goes with M, the E goes with L, and finally G will go with N. That's our similarity statement, and we prove that by angle-angle similarity. Let's look at our next one. So angle-angle, side-angle-side, or side-side-side. We see some side measurements, so I definitely feel like we could use either side angle side or side side side. When you're given these side measurements, make sure that you pair up long sides with long sides and short sides with short sides. The 27 we would not want to pair up with the 24 because 27 is the shorter of these numbers that are provided and 24 is the longer of these numbers that are provided. So it definitely would not make sense to pair up in any other way than long sides with long sides and short sides with short sides. So 36 to 24, we want that to equal 27 to 18. So we will want to reduce these fractions. We could divide by 6. I really think we can reduce even further. Yes, 36 and 24 are both divisible by 12. Of course, you could just keep reducing a little bit at a time if you didn't know that they could reduce by 12. So 36 divided by 12 gives us 3. 24 divided by 12 gives us 2. And then we can also reduce 27 over 18. They're both divisible by 9. And we want to see that it is also going to equal 3 halves. So 27 divided by 9, 18 divided by 9, it does work out. So those sides are proportional. So far it's looking pretty good for either side angle side or side side side. We could not do side 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 because we don't have this third side to also make sure that they're proportional. However, we do have this angle here and here that are vertical angles, so that allows us to call it side angle side. So triangle ABE, again, however you want to name that triangle using the 3 letters. It does not have to go in that order. You could have said EBA, any 3-letter combination, but once you name that and you write your similarity statement, the corresponding sides have to line up. So A, remember that was the shorter side with the non-labeled side. So we're going to come and pair that up with D, because again, that's the shorter side with the non-labeled side. So A corresponds with D. We went to B next, so after A to B, D will go to B. And of course, our last letter, E, corresponds to the C. That does matter in your naming, that the corresponding pieces line up in that similarity statement. And we proved that by side angle side. Question number 7. We're going to write the sine, cosine, and tangent ratios and their inverses for the given angles. So our angle A is going to be our theta angle. Let's go ahead and label our triangle, and then we'll set up each of our ratios. So the hypotenuse is usually the easiest to first label, because you know that that is across from the 90-degree angle. Then from the theta angle, the opposite side, and then finally we have the adjacent. Opposite, adjacent, and hypotenuse. So sine of our angle, so sine of 53, sine is some old hippie, so opposite hypotenuse, 8 over 10. Cosine of 53, so cosine is caught another hippie, adjacent hypotenuse. And then finally, tangent of 53. Tangent is tripping on algebra, so opposite and adjacent. To do their inverses, we actually start with the angle first. So 53 equals the inverse of that same ratio, 8/10, which is opposite over hypotenuse for sine. We can also do inverse cosine. So the angle equals the inverse cosine of the adjacent over hypotenuse. And then finally for inverse tangent, 53 degrees equals inverse tangent of 8/6, the opposite over adjacent. Question number 8. In the right triangle, angle C is the 90-degree angle. So that means that the other two angles, A and B, that are left over would have to be complementary angles. There is a rule that says when you have complementary angles in a right triangle, the sine of one angle, so the sine of one angle equals the cosine of the other angle. And that is true for all right triangles. For the complementary angles of the right triangle. So if this is x and this is y, sine of that angle x equals the cosine of the other angle y. So sine of b, we're trying to find sine of b. It's not going to equal sine of a. Sine does not equal sine. Sine of b equals the cosine of a. So that means this one is going to be 12/13. No work here, just needing to know that the sine of one angle equals the cosine of the other. So that means for this next one, cosine of B is going to equal the sine of A, which is 5/13. Question number 9. Ryan is using a cone to fill a cylinder with slime. If the radii and height are equal in both objects, so that's saying the cone and cylinder have the same radius, have the same height, then Ryan's going to fill the cone to the very top. How many of those cones will it take to fill the cylinder with slime? Remember, we watched a video of this actually being done, and it takes 3 cones to fill the cylinder. And that is because the volume of a cone is 1/3 the volume of the cylinder. And that's true for any pair of shapes that have the same base area. Because these have the same radius, they have the same base area, and they have the same height as it's mentioned here. It will take 3 to fill in the other. Finally, here for number 10, we have a fish tank in the shape of a rectangular prism. That's helping you know what formula to use for our volume. It holds 30 cubic feet of water. The tank has a length of 5 feet, a width of 3 feet. It's asking what is the depth in feet of the tank. So first of all, because we know it's a rectangular prism, we're going to use the volume formula, length times width times height. Well, it actually gave us the volume, 30 cubic feet, so put that in for V. It also gives us the length, plugging that in for 5, and it gives us the width, plug that in for 3. What it does not give you is the depth, which is the same as height, so we're actually going to solve for H. First, let's multiply the 5 times 3. So we get 15H equals 30. In order to solve for H, you would need to divide by 15. 15 goes into 30 2 times for our height. So we're going to have a height of 2 feet for the depth of that pool. Or fish tank, sorry. Fish tank, not a pool.